In this lecture, we will discuss implementation of double linked list. Implementation of double linked list. The operations are performed on double linked list. Implementation of double linked list. In the previous video, we discussed single linked list and its operations and double linked list. How can we perform the operations? So now we will discuss how to implement double linked list operations in C. First we will discuss insertion operation in double linked list. Okay. So now let us start with the programming. So first, as you know, include the header files. Standard input output header file. If you are ready with the system, try to execute the program with me. How I am writing the program, in the same manner you too try to execute the program. Then it is easy to understand the program. Okay students? Right. So hash include console input output header file. You know double linked list consisting of 3 partitions. Okay, that is node structure I am giving. Struct node. Then so one is data partition and another one is next partition and previous partition. Okay, so now head node will present at the beginning of the node star head, and another one we are taking as a PTR as global. Now we have to create the list. How to create the list? So DLL creation. How to create the list? So void create integer. Which element you want to insert in a node? So that we are passing as a parameter ELE. What does it mean? This means ELE. We want to insert ELE. We want to insert ELE. Okay. So now to insert a new node, what we have to do? We have to create a new node. Struct node star new node. Struct node star new node. NEW we will take. Struct node star new node. Okay. So now for this new node we have to allocate memory. So that we are allocating. So new node equal to struct node star dynamic memory allocation function in C, malloc. So malloc, how many bytes of memory do you want to allocate? That we don't know. That's why one special operator is there, size of operator. So how much size you want to allocate? Node, how many bytes occupies? Those many number of bytes we want to allocate. So here every time PTR should present in the beginning of double linked list. So that's why we are doing that. Okay, we are allocating new node. So now new node memory. So now we have to change the pointers. First we have to move pointer to the last node. We are adding a new node at the end. Okay, pointer is moving to the end position. How to move pointer to the ending? While PTR of next not equal to null, then PTR equal to PTR of next. What is the meaning of this statement? This means moving pointer to the next node actually. That we have to repeat until the last node. So that's why here we have taken, see this one, PTR of next not equal to null. Until last node we have to move the pointer. So now we have allocated memory. We will save the program. DLL.C. Right. So we moved pointer to the last node. Okay. So then we have to allocate memory, that already we have done. Then we have to modify the pointers. Modify the pointers. As it is double linked list, so we have to allocate memory dynamically and we have to give the links. How can you give the links? New nodes next. New nodes next. Okay, equal to PTR of next. If you have any doubt, you just see double linked list insertion operation. There we have given the links, like that only we will give. New nodes next equal to PTR's next. Then after that, so PTR's next equal to new node. Then new node previous equal to PTR. That's all. Creation. So that means we are adding a new node at the end, creation of list. Now we have to display the nodes, otherwise how can we know that the list is created correctly? So that's why we will display whether elements are inserted or not correctly. So void display. So now how to display? Simply we will move first PTR to head node. See, here we moved pointer to based on the operation we are moving pointer to the end. Now again PTR has to come back to beginning of the list. So that's why beginning of the list we have moved. So now we have to display the elements present in the list until last node. So PTR of next not equal to null. Then we have to simply print. So %d/d spaces we are giving. Then PTR of next of data. PTR of next of data. Then move pointer to the next node. What is this one? We have to move pointer to the next node. See, for example, in suppose these are the elements present. Suppose press insert key whenever cursor we get like that. So suppose the elements are like this, 10, 20, 30 like this. Now initially here it is the head node, for example. This is head node, na? So now initial PTR is also present here. Okay, so now we have to display 10, 20, 30. That means PTR of next means this one not equal to null. Then next of data we have to print. After that pointer has to move to the next node. Now move pointer to the next node. Now PTR will come to this position. Again PTR of next not equal to null. See, 20 is there. That's why here not equal to null. Then what we have to do? PTR of next means this one, of data means 20. So 20 will be displayed. Then move pointer to the next node. Move pointer to the next node means, yeah, move pointer to the next node. Again PTR of next. See the condition, it is a loop. Loop means it continues until the condition fails. So PTR of next not equal to null. 30 is there, so it is not equal to null. So PTR of next of data, 30 will be displayed and move pointer to the next node. PTR of next, there are no elements after 30. So that's why PTR's next not equal to null condition will fail. That's all. So it comes out of while loop. That's it. So I'm deleting this. Like that we can display the nodes present in double linked list. Now coming to main function. So in this, just we will call the functions. First we have to initialize the header. Initially list is empty. So initially list is empty. Okay. So wherever head is there initially, PTR will be there only. So PTR equal to head. Now we will call the function 10. We are creating the list. What is the meaning of this one? We are creating the list. Okay. create of 20, then create of 30. After calling this create function, if you display, then only we can know whether the list is created correctly or not. So that's why we call the display function. That's it. Now save the program once, compile, see errors we are getting. So if errors are there, don't worry, read the error, try to understand the meaning of the error, then rectify it. See what is the error you are getting? Open curly brace expected and line number. It is not struct directly star, struct node star. Next save it. Yes, compile. One warning you are getting, element. Yeah, here what happened, in the new node we have to insert the data na? So new node of data equal to element. So element is inserted. Execute the program. See 10, 20, 30, the elements are inserted. Before that, simply we will give the message, the doubly linked list elements are. Here simply we will write a message in printf, the elements, hope you are doing with me, then it is easy to understand. Okay, printf the elements present in DLLR, quotes, double quotes, close. Now see, it is easy to understand. See, the elements are present in DLLR. Now simply I will give you a clear screen. We will give clear screen. CLRSCR. Compile, execute. The elements in DLLR. That's it. Now what we have done here, we have created the list. We have not at all performed insertion operation. Okay. So implementation of double linked list, especially insertion operation in this video. Okay. Now list is created. Now here we will insert. So how to insert? Void insert of integer. To insert an element, so first element is required and in which position you want to insert, that PYS. Now, so this is insertion operation. Some steps are similar to single linked list insertion operation, like moving pointer to the new node, allocating memory dynamically. These are similar to SLL insertion operation. You please see that video if you are unable to get these points. Okay. So now we are inserting a new node, means we have to declare a new node first. So new node and integer I, which is initialized to 1. Any more variables? No variables are required. So now, right, first what we have to do, move pointer to the required position. See, for example, the elements are 10, 20, 30. Here head PTR will be there. Okay. So now, suppose I want to insert in second position. This is first position now. This is first position. This is second position element. This is third position element. If I want to insert in second position, what shall I do? Here you have to insert. Then it is first node and this one second node, third node, fourth node, like that. Okay. So now whenever you want to insert in second position, we have to move pointer up to first position. Why? Because you have to give the links between these two, between 10 and 30. So that's why we will move pointer up to the required position, which is nothing but, if it is the second position you want to insert, then in the up to first position you have to move the pointer. So now see how can we move pointers. It has to repeat na. So while PTR of next not equal to null and I less than PYS. Now observe here, move pointer to the next node, ptr equal to ptr of next. Yeah, here we have to initialize the ptr na, ptr equal to head. All it has to come to first position, and then I plus plus. Now we have to allocate memory dynamically. Allocate memory for the new node. How can we allocate memory dynamically for the new node? By using MLOC it is possible. New node equal to struct node star by using MLOC of size of struct node. We allocated a memory for the new node. Now we will give the links. First we will insert the data. New nodes data equal to element. Then say for example this is the list 10 for example here 50, for example here 34, for example here 23. Okay, so now in between these two we have to insert. Okay, that means now we have inserted. This is in between here, this is a new node and this is ptr, this will become ptr's next. Okay, so new node of next equal to, if you are unable to understand the links modification, you please see double linked list insertion operation with example in my previous lecture. Okay, so new node of data equal to element. Okay, already we have written new nodes data equal to element. Now new nodes next equal to ptr's next. New nodes next equal to, see how we are giving new node next is nothing but, so in between these two we are giving. So this is ptr of next means this. So here we have to insert this address. Okay, now ptr of next previous equal to ptr of next previous. Ptr of next previous means ptr of next means this one of previous. For this 50 node, which one is a previous node? That new node. Okay, so that's why ptr's next of previous equal to new node. Then new node's data equal to element. Okay, so now new node's previous. New node previous equal to ptr. This is simply insertion operation in double linked list. After insertion we will call this display whether it is inserted correctly or not. Now, so after display here I am calling the function insert of 100 comma 2. After that we have to display now. So again display. If you are not calling that one, definitely you won't see the correct answer. Okay, though you are getting correct answer, you can't see. Okay, so this is compiled. Now execute the program. See, declaration is not allowed here. So now what I said, so whenever you are getting error, so you don't worry, read the error and rectify. You can rectify. Okay, after declaration only you have to start the logic. Okay, now we have to delete all this. This is for your understanding only I mentioned. Still you are getting an error. Now new nodes data, new nodes next. Here it is, new nodes next. Already here new node data, the first step itself new nodes data. Again no need. Save. New node 4 pointers here you have to get na. New nodes next equal to ptr's next. Then ptr's next previous equal to new node. Then new nodes previous. ptr's next equal to new node. Then ptrs next equal to new node. That's it. Save, compile, execute. See, here I will write a simple message after which operation we have displayed. Okay, so this after insertion, printf after insertion /n. Okay, compile, execute. See, the elements are present in DLLR originally 10 or 20 30. Now we want to insert 100 in second position. That's why in second position. See, after insertion you are getting in the same line, so that also we will change. In main function we have written /n. Save, compile, execute. See, after insertion the elements are present in DLLR in the second position, 100 is inserted. So in this way you can perform insertion operation in double linked list. Hope you understand, students. If you have any doubt, please post the question in comment box. If you like this video, please share the video to your friends and subscribe the channel. Thank you. Have a great day. Bye.